Hi everyone, this is a prospectus for the computer science course that we offer. One of the good things about this course is we get to learn how to program things properly and make stuff that actually would be useful in the real world. A great deal of this course is spent learning not only how to actually do the programming with the syntax you see before you using Python, but also how to look at an issue, break it down, provide an algorithm to try and think how you'd solve it, and then program based on that algorithm. So one of the things we look at is understanding how a computer works. The bits in the middle show the components that we learn all about in year 7 and 8, so the processor, the storage, the memory. And what we have to do in year 10 and 11 is really go into a bit more detail in each area. For example, the processor, we need to understand something called the von Neumann architecture, how it actually works beneath the bonnet. Storage, we did do this in year 8, looking at primary, secondary and offline storage. And the memory, we go into, again, more detail, understanding what registers are, what cache does in terms of the performance of a computer and how they interact with the RAM. Clearly, some of you have got some ideas about how we connect devices together with your home Wi-Fi. It's very different than the way that computers are connected at school, which uses LAN, and you also see the expression WAN there. So we're going to look at the way that networks are formed, how they're actually put together, and how they operate. I find this is one of the most annoying issues with students, in that we use www, World Wide Web, and the expression the internet to mean the same, where they're not. The images at the top show the hyperlink between a Word document that shows bbc.co.uk and the website for the BBC. The World Wide Web is just a series of hyperlinks to documents that are on different places around the internet. The internet itself is the thing at the bottom. It's the hardware that we use to connect all the devices around the world. You'll see I've got PCs, there would be servers, routers, even fridges, random devices. Okay, so we go into quite a bit of detail about how these things differ. So with any course we offer at Lavington, we want to see a pathway from where you are in year 10 to real life jobs, basically. The pathways you can see, we have computer science at GCSE. We would link that into computer science at A-level at a sixth form college in the local area. And then we have the different university courses. Now, I've just picked two here that were at the University of Bath, where they offer computer science degree and a computer science and artificial intelligence degree, which sounds amazing. So at the end, you're going to have some really top level skills, one would hope, and that should lead to a fantastic job. You're very empowered, friends you choose, and autonomy to make life decisions. So it's a really quite a well-paid industry as things stand at the moment. So that's why we think it's a valuable qualification route to pursue. How are we assessed in computer science? Well, we use the exam board OCR, and you will end up doing 2 hour-and-a-half exams. There's also a programming project which lasts for about 20 hours that you have to complete. So you'll have a portfolio of programming projects that you could show to prospective employees in the future. In terms of the examined units, Unit 1, Computer Systems, as I said previously in this video, we look at the hardware, the way that the computers are put together, how they are networked, how you would make sure they're secure, massive thing at the moment. And possibly one of the more interesting things is the point at the bottom, where we've got this ethical, legal, cultural, environmental impacts of digital technology. The point I'd like to pick here is we are facing, over the next generation, a switch from many jobs to automation. So the jobs will be taken up by robots. What do people do then? What jobs do they do once their jobs have been taken? So it's a very difficult one to answer, but certainly it provides very good discussions within the class environment. Unit 2 is based more on the programming side. So algorithms mean, can you plan a step-by-step approach to solving a problem? We look at the programming fundamentals, the key terms, many of which we've started in year 8 and 9 and 7, to use things like variables and functions. Producing robust programs means that they don't go wrong. Okay, so we test them effectively, and as I said, the overall aim of the unit is for you to leave here with a really good understanding of how programming works in the real world. I hope that's been useful. Thank you.